Hello, this is NK Sri Balaji, 17 BCI 0023. I'm going to be giving the introduction and the importance of the application. So, data mining is the process of obtaining useful information from a large set of available data. The database is given to some trusted third party so that the useful or statistical information can be obtained from the available information. When data in tabular format is given to some miner, there's a high possibility of leakage of data so that the individual's identity might be revealed. To avoid this leakage, there are many techniques for the anonymization of the data: generalization, slicing, suppression, shuffling, etc. But each of these techniques has its own pros and cons. Data mining can be seen over various sectors like finance, communication, military, healthcare, and so on. Here we would try to take a case. For instance, a medical facility database which is trying to preserve its privacy. So, when a medical facility gives its database to some miner to basically do the data science operations, he would like to preserve his patient's data and still get the statistical information out of it. So basically, when he anonymizes the data and gives it to the miner, and the miner can use it to extract the statistical information but still preserve the identity of the patient. Here comes the importance of application. The need for an efficient system for medical facilities and medical sector is actually high now than in previous decade. This is due to the increase of snoopers and hackers. Every system with anonymization involved faces a great problem, which is preserving the data and protecting at the same time. Through the use of given models, the aim is to optimize the anonymization. So thank you.
Hello, my name is Shiraz, and for this part of the presentation, I'll be explaining the problem statement, the objectives, as well as the applicability category. Now, in the first slide, the problem statement, we get to see that what we're trying to do over here is to develop a patient data anonymizer for the medical facility with the help of the standard shuffling, standard generalization techniques and the models. And we're going to use generalization k-anonymity to do that. Generalization through the use of k-anonymity. That is the problem statement. Next slide, we will see objectives. The first one is to use various anonymization techniques provided to us to find a much more efficient method. Second one is to avoid any overprotection. That is, overprotection leads to loss of data that a person can see, the data analyst can see, or anyone else can see. So to avoid that, we are trying to efficiently maneuver around that using the methods we have. Thirdly, we are trying to take into consideration the medical records that are there stored, and for the doctors to be able to see that without any hindrance, so that they can easily see the product data with the help of the patient's permission. Next slide. Applicability category. Over here, we see that it is applicable mainly in the healthcare sector, and now primarily what we see is that the healthcare sector has patients with many different factors like patient ID, patient mobile number, or any of their where they were born, any other personal data, the names, whatever disease they have also had. That is also very primary. So to protect that, we see that the healthcare sector wildly needs this. And what we are trying to do is that our main aim over here is to provide a secure mechanism for the patients who miss their appointments. So that suppose they're going for any doctor appointments for a particular disease, to avoid any of that data being leaked out to data snoopers, we're trying to develop a method and a technique over here. So that is what the applicable category is. Thank you.
Hey guys, this is Harshan. I'm going to explain about the literature survey of our project. Our first slide, generalization step-step algorithm in anonymizing data. This paper solves the problems of information loss on data when preserved. But using anonymization labels, still the data can be broken and the privacy is very low. So we propose in the second slide, we propose a system. The defect of the data is preserved by SSGK and GSSK algorithms. This can reduce the information loss over the data. To the next slide. In this slide, we have a second paper that slicer based anonymization privacy preserving. In this paper, they mainly explained about two things, that is multimedia data preservation and the data which is transmitted over the communication level, that is network level. This type of paper has a defect that the conventional method of anonymization is very low. The privacy preserving of multimedia data is actually not achieved, can be achieved in a better way. Um, in our next slide, we have a solution. That is, by increasing the intent efficiency of a slicer, this algorithm can achieve a high data accuracy with a low loss and a low computational overhead. To the next slide. Here we have our clustering based anonymization algorithm. This project explains about the loss of personal data over social media. And to the next slide, we have our solution here. That is, the suppression of the data cannot be done without the efficiency. But in the system, we made an anonymization by suppressing the data. Also, they lost their efficiency. So, moving on to next slide. Multi-attribute generalization in a privacy-preserving data. These types of data are mostly prone to attacks. Securing privacy model for vertical partition distribution table. Vertical partition distribution tables are actually used in data mining things. Data mining, the data sets are mostly used for surveys and statistical purposes. This data can be easily penetrated and information is very high. To the next slide. Distributed mining research and attributes on horizontal partitioning data. This is same as the previous paper. This also has many losses. The hybrid approach for preserving the data using data mining. This paper is actually good. They preserve the data by increasing the anonymity and also the efficiency. We taken this paper as a base paper. Thank you.
This is Thiyagarajan, registration number 17 BCI 0177. The topic that I've taken up is on architecture models for the concerned topic, for the concerned project title, and we'll be taking the quasi identifiers of the data set. So we'll be scrutinizing based on the unique values that it possesses, and so that will be the first tasks that we'll be doing with regards to the project. And after that, we'll after receiving medical data set in this case, and after selecting the QI with the highest number of unique values for each attributes, we'll be performing what is called as selective generalization. So it is part of the SG model that is being developed in accordance of kind of providing generalization algorithm in case of this particular data set. And we'll be deploying this particular model firstly to provide some variations in the given medical data set, and it will provide a series of AAM sets of attributes in correspondence. And next we will proceed with a phenomenal corner slicing, in which we will provide a randomization of sorts on top of the generalized part of SG algorithm. So we'll be taking those attributes and we'll subjugate that to slicing, and then we'll be taking up SS model, which is called a selective shuffling. So the flow chart as described in this model goes by this kind of flow. After doing the SG generalization, there will be SS model providing the shuffling mechanism to ensure that any uniqueness whatsoever is being remained within those attributes, the quasi identifier, so that the cross-linking with other sources is not revealed of sorts. So this SS model ensures through shuffling it could better anonymize the data. And then after the shuffling is done, we will get the anonymized protected data. So this is the model that justifies the entire flow in the mechanism.
Moving on to the requirements of this project, we are going to be using two softwares. First one being ARX, which is of the version 3.8.0, and the second one being Amnesia, which is of the version 1.1.1. ARX is a comprehensive open source software for anonymizing sensitive personal data. It supports a wide variety of privacy and risk models, methods for transforming data, and methods for analyzing the usefulness of output data. ARX is able to handle large data sets on commodity hardware, and it has an intuitive cross-platform GUI. The next software is Amnesia. Amnesia is a data anonymization tool that supports k-anonymity. Amnesia allows the removal of identifying information from data. It not only removes direct identifiers like names, social security number, etc., but also transforms secondary identifiers like birth date, zip code, so that individuals cannot be identified in the data. Next slide. We will be using the 5th version of dataset of medical appointments no-shows. The dataset being used consists of attributes which are patient's ID, appointment ID, gender, scheduled day, appointment day, age, neighborhood, scholarship, hypertension, diabetes, alcoholism, handicap, SMS received, and no-show.